This is Math 6, Lesson 3-6, Solving Subtraction Equations. In the last lesson, we learned how to solve equations by subtracting the same amount from each side of an equation. You can also solve equations by using addition as well. Remember the teeter-totter and how we need to keep it balanced. If we subtract the same number from each side, we will keep our equation balanced, just as if we add the same number to each side of our equation, we will keep the teeter-totter balanced. If you can add the same value of each side of an equation, the two sides will remain equal. In the arithmetic way, that says that 2 times 3 equals 6, so 2 times 3 plus 4 is the same as saying 6 plus 4. If A equals B, then A plus C equals B plus C. Some equations have a number subtracted on one side. To get the variable by itself, we will add that same number to each side of the equation. Again, your equations are divided by the equal sign. The equal sign is like a little invisible fence that divides one side of your equation from the other side of the equation. Whatever side of your equation has the variable wants to be by itself. Remember that signs go in front of numbers, so subtraction signs go in front of the number and not necessarily the variable. So in the first equation here, n minus 53 equals 28, the negative sign goes with the 53. So we have subtracted 53 to n. n has 53 subtracted from it. In order to get n all by itself, we need to add 53 to both sides of the equation. By doing this, adding 53 and subtracting 53 cancels the 53 out, leaving n all by himself, which he likes because he does not like having any neighbors. And then we look at and add 28 and 53, which happens to be 81. Remember, we can check our equations, which I highly suggest you should always do. If I check my equation, I check it by saying 81 minus 53, does that equal 28? Well, let's find out. 81 minus 53, let's see here. 7, that's 11, 8, 7 minus 5 is 2, 28 equals 28. This equation definitely checks out. Highly suggest you always check your equations. Number 2, if we look at number 2, x minus 43 equals 12. 43 was subtracted from x. In order to get x completely by himself, we need to undo that subtraction by adding 43. So I will add 43 to both sides of my equation. By doing that, the 43's on the left-hand side cancel out, and on the right-hand side, I have 12 plus 43, which happens to be 55. Again, I will check my equation. 55 minus 43, does that equal 12? So let's see, 55 minus 43, 5 minus 3 is 2, 12 does equal 12, it does check. Let's look at a couple more equations. And it doesn't matter if you have decimals or whole numbers or fractions, the rules stay the same. If I subtract something from my variable to get my variable by itself, I must add the same thing to both sides of the equation. Absolutely every single time, if you do something to one side of the equation, you must absolutely, positively, every single solitary time, without fail, do the same thing to the other side of the equation. If you don't, it will not be balanced. So we will add 3.2 here to both sides of our equation because they subtracted 3.2 from m. Subtracting 3.2, adding 3.2 becomes nothing. So m equals 6.7 plus 3.2, which is 9.9. Okay. Again, check your equations. It's a good habit to get into. So I want to know 9.9 minus 3.2, does that equal 6.7? Let's find out. Let's put 3.2 under my 9.9. 9 minus 2 is 7. Line up my decimal points. 9 minus 3 is 6. 6.7 does equal 6.7. This does indeed check out. Number 4, 7.9 equals n minus 0.35, or 7 and 9/10 equals equals n minus 35 hundredths, or 35 hundredths less than n. Okay. Here, to get n all by itself, 35 hundredths was subtracted from n, so I need to add it to n to make it equal. Make sure you line up your decimal points. If you do not line up your decimal points, you will have some problems. If you can't fit it neatly over there, do it over here. Do it over here so you can make sure that you line up your decimal points nice and neat. Otherwise, you could make some really bad math mistakes, and you don't want that to happen. Okay, 9 and 3 is 12, carry my 1, 7 and 1 is 8, so 8.25 equals n. Okay, if you have to make things bigger so that you can actually see them, I highly suggest that. It's a good idea to be neat. Neatness counts in mathematics, and it is kind of important. Let's look at some word problems. Another way to model a real-world situation is to state the problem as simply as you can, and then use that statement to make your equation. For example, the temperature dropped 9 degrees Fahrenheit between 7 p.m. and midnight. It was 54 degrees Fahrenheit at midnight. Use an equation to find the temperature at 7 p.m. So first of all, I'm looking at this and going, it says I need to find the equation at 7 p.m. Find the temperature at 7 p.m. So that's what I'm looking for. I'm looking for the temperature at 7 p.m. Okay? So that's the one thing I need to keep in my head. I'm looking for the temperature at 7 p.m. So the first thing I'm going to do is I'm going to let T equal the temperature at 7 p.m. Because that helps my brain be able to start to think through this problem. Now I need to try to figure out what this problem is asking me. The temperature dropped 9 degrees between 7 p.m. and midnight. It was 54 degrees at midnight. So basically it's saying that the temperature is 9 degrees Fahrenheit less at midnight than it was before. Okay. So in other words, the temperature at midnight was 9 degrees colder than the temperature at 7 p.m. Okay. Okay. So if I look at this and I say, the temperature is 9 degrees, okay, my temperature now, okay, is 9 degrees less than it was at 7 p.m. or the temperature at midnight was 9 degrees less than it was at 7 p.m. Okay, so if I take the temperature at 7 p.m. and I subtract 9 degrees from that, I will get the temperature at midnight. Okay. That's what I'm trying to say here. What I'm trying to do is go, if I know my temperature at 7 and I subtract 9 degrees from that, I get my temperature at midnight. So temperature at 7, which I don't know, so that becomes my variable, minus that 9 degrees equals my temperature at midnight, which was 54 degrees. So I simply have my equation now. I go, there we go, there's my equation. The hardest part for people when they first learn how to solve equations is how to get a word problem into an equation. You know what you need to do. Your brain says, take 54, add 9 degrees, that's going to give me the temperature. But that's not an algebraic equation. You have to work at trying to understand how to write an algebraic equation. If you can do it for the easy ones, when you get to the more difficult ones, it'll become a piece of cake. So, in order to solve this, to get the temperature by itself, I will add 9 to both sides. These will cancel, so T will equal 63. And what was I looking for? The temperature at 7 p.m. So the temperature at 7 p.m. was 63 degrees Fahrenheit. So there we have our solution. Temperature at 7 p.m. was 63 degrees Fahrenheit. Let's look at another word problem. Sheila is 2 years younger than Javon. Sheila is 10 years old. Write and solve an equation to find Javon's age. So, first thing we do is we look at this and we go, I am supposed to find Javon's age. That's what it's asking me to find. So I think I should let a variable equal Javon's age. Javon starts with a J, so I'm going to let J equal Javon's age. That's what I need to find. Now, I need to see if I can figure this out. It says Sheila is 2 years younger than Javon. That's really important. That means Sheila is 2 years younger than Javon. I can use that whole phrase right there. Just that portion of the question here can give me my entire equation. Sheila is 2 years younger than Javon. Okay, so let's just use that part. So if I write that, Sheila is 2 years younger than Javon. From that simple sentence, I can write my entire algebraic equation. Sheila, her age now, okay, is 10 years old. Sheila is. She is. So she is 10. Is in math means equals. 2 years younger than. Remember when we talked about writing equations? Younger than means she's younger, so Javon has to come first. So 2 years younger than Javon. Okay, Javon's age minus 2 equals Sheila's age. That's basically what it's saying. Javon's age minus 2 years equals Sheila's age. So there's our equation. 10 equals J minus 2. If you add 2 to both sides, you now have 12 equals J. So Javon is 10 plus 2 becomes 10. That was silly. 10 plus 2 becomes 12. There we go. Javon is 12 years old. So Javon is 12 years old. And then the last thing you should do is make sure your answer makes sense. It tells us Sheila is 2 years younger than Javon. Well, if Javon is 12 and she's 10, yeah, that makes sense. Perfectly logical sense, so Javon is 12 years old. And this ends lesson 3-6, solving subtraction equations.